What's up, everybody? Today we are going over our Module 3, Unit 1 test review. And this unit is all about similarity and mostly dealing with similar triangles and the properties that we saw. So let's hop right into it and let's review some things and go over some questions. Our first question, once again, we're dealing with similar triangles, and this is going to bring up the ratios that come up at which create proportions, which just means that two ratios that are equal to each other. So it says Victoria's holding a 5-foot long fishing pole. The fishing line extends 3 feet to the water's surface and another 12.6 feet to the hook. How far is the fishing pole? How far is the fish from the hook? The one thing we need to know is that our hook is here. This is where the hook is, right? It doesn't label it for us. We're going to say a hook. And then another thing we have to assume is that this 5 feet is from this line of sight to the tip of that fishing pole, right? It says the fishing pole is 5 feet. We can't do the problem that way. So one thing that we need to assume is that's the 5 feet they're talking about. So now that we assume that this is the 5 feet and we have our hook down here, we could tell that these two triangles here are similar because they also have vertical angles here, right? And vertical angles are congruent. And then they have right angles and they're congruent. So we have angle-angle similarity. Then we can set up our ratio. So the way this ratio is going to be is it's going to be 3 over 12.6 equals 5 over x. And now all we have to do is our trusty dusty cross multiply like we've been doing. Get 3x equals, and multiply 12.6 times 5. Once again, don't be afraid to use a calculator if you need to. The Desmos scientific calculator is my favorite. I know y'all like to use the calculator on your phone. They also have a Desmos scientific calculator app. It just, trust me, it works better, easier to understand everything that's going on there. So I suggest getting it if you have the space on your phone. So 12.6 times 5 is 63. So last but not least, all we have to do here, divide both sides by 3, and we get x equals 21. And this is going to be 21 feet. There is our answer. Awesome. Next up, it says segment BD bisects angle B. Solve for AC. So when we say something bisects it, tells us that we have these two congruent angles here, right? And this is one of our theorems that we learned throughout this module, which says that when we have a bisector, an angle bisector, going across and intersecting the opposite side, the two sides, or the two new portions that are created, can create ratios, right? So this is asking us first to solve for AC. In order to do that, we need to find DC. So I'm going to throw an X in here. And now what we could do is we could set up our ratios, which then lets us set up the proportion. So first of all, we're going to do 6 over X. These are the two segments of AC. Equals 14 over 16. Now notice, 6 and 14 are on the same side of this bisector. They're above it on the same side. And then X and 16 are on the same side. And here, 6 and 14 are both up top, same side. And then X and 16 are both down below, same side, same type of thing. When we set things up, we have to make sure we are consistent. Then, next step, same thing over and over. A lot of cross multiplying in this module. We cross multiply. We get 14x equals, we have to do 6 times 16. 6 times 10 is 60. 6 times 6 is 36. So add those two together and we get 96. And last but not least, what do we have to do here? We divide by 14 on both sides. And that's going to leave us with x equals, once again, just to be safe, I'm going to plug this into my calculator. We do 96, divide it by 14, click enter, and we get a decimal here. We get a decimal on this one. Our decimal is going to be 6.8, and we're going to round it off to our hundredths place. It says 5, and then 7 comes after. So since that 7 comes after it, we're going to round up to 8, 6, right? That's not our final answer because that only tells us what x is. What we have to do is say AC equals 6 plus 6.86. So finally, AC equals 12.86. Awesome. All right, next problem. Our next problem says, I think that's Corinne, right? We're going to call her Corinne. I don't know what that name is. But Corinne is visiting a local amusement park, and wants to know the distance between the log ride and the pirate ship. Use the drawing to determine the value of x. Now, you guys have seen a problem like this before, right? So let's go through and complete it. So if we look here, we have the roller coaster up here, Ferris wheel here. We have the big top tent, log ride. And we also have angle markers to show that we have angle-angle similarity within these two triangles, which means that we could set things up. Now, we could also use these angle markers to determine what sides match up together and are proportional, right? And the way we're going to do that is notice our one angle marker is on the left side of our top triangle, but on the right side of our bottom triangle. So the side that goes from that angle marker to the middle here, up top, which is 10, and the side that goes there in the bottom, which is x, they are the ones that match up. They're the ones that are proportional. And then 9 meters and 6 meters are going to be the proportional because they're going from the double angle marker to the center. So that's important because if we did 10 over 9 and 6 over x, we would not get the right answer for this. That's one thing to keep in mind. Sometimes they try to switch it up. But I am going to take 10, throw it over x. So we're going to say 10 over x equals, and then we're going to do 6 because it's from the same triangle as 10. So that's going to be up top, over 9. Now, one thing we notice, since 6 is over 9, whatever our x is has to be bigger than 10. That's just a little fun fact, a little tidbit there for you. Now we cross multiply like we have been. We get x times 6 will give me 6x equals, and we do 10 times 9, which will give me 90. And then we just solve this. One-step equation. Since we have a 6 next to our x, we have to divide to get rid of it. 6 on both sides. Got to keep that scale even. So we got to do the same thing to both sides there. Our 6's cancel, and we're left with x equals, and we just have to do 90 divided by 6. Once again, don't be afraid to use a calculator here, right? Calculators are your friends. Back in the day, they said, "Oh, you're never going to walk around with a calculator in your pocket." Well, they were wrong. Everybody got a calculator in their pocket if you have a cell phone. So 90 divided by 6 will give us 15. Whoops. Give us 15 meters. There we go. Found our answer. That is the distance from the pirate ship to the log ride. There you go, Corinne. There's your answer. Moving on. Next up, it says consider the line segment AB shown. We have that line segment in our graph. Now, this is switching up what we're doing. It's our last topic of this module that we went over, dividing segments into ratios, right? So it says determine the coordinates determine the coordinates of the point that divides directed line segment BA into the ratio 1, 3. So we're going this way. So one thing to know about ratios is when we have ratios set up like this, that means we really have to divide this line into 4 parts. That's what we're trying to think of here, right? So we're dividing the line into 4 parts. So I'm going to show you guys a couple ways we could do this with this graph. One way is just using the idea of this graph and using the idea of slope. So rise over run. So one thing to keep in mind here is what we could do is we could do our rise over run, but we want to go from B to A. That's one thing to keep in mind. We're going to go down 1, 2, 3, 4. So our rise is a -4 since we went down. And then our run is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since we're going left, it's going to be negative again. So we got a -12. So what we could do is we could write this in a fraction over here and do some work. We could say -4 over -12. And now a lot of us are like, hey, we can simplify this. Divide both the top and the bottom by -4 and it will turn into a 1/3 positive. We don't want to do that. Although, yes, we can do that. We don't want to. And the reason we don't want to is because right now the negatives are telling us direction. And also, I want to do something else. Now, yes, we can divide it by 4. But the reason we're going to divide it by 4 is because our ratio is asking us to separate this into 4 parts. 4 parts. Right? And now, what happens here is what we want to do is divide this by 4. So we're going to divide the top and the bottom by 4. And just remember, this is my rise over run, our slope. Now what we could do is we could divide the top and the bottom by 4. That's what we're going to do here. And that's going to equal -1 over -3. And what we're going to see happens here is we're going to do that from B going to A, and we're going to put a point along the way each time. So my first one, we'll do them in different colors just to keep it a little organized. So the first one, we go down 1, because that's what that -1 tells us, and then left 3. 1, 2, 3. We put our point down. And then from that point, we go down 1, left 3. 1, 2, 3. We put a point down. And then from that point, we do it one more time. We go down 1, left 3. 1, 2, 3. We put a point down. And then what we'll notice is the last time we do it, which will be the 4th time, we go down 1, 1, 2, 3. It lands us onto A, which is perfect because now look how many segments we have here. From A to the purple point is 1. Purple to yellow is 2. Yellow to red is 3. And then red to B is 4. So if we want a point that divides our directed line segment from B to A into a 1-to-3 ratio, which means 1 part before the point and 3 parts after, 3 equal parts after, right? That's the most important thing. All these parts are equal. So what that will be is going from B to our red. That red point is the one that divides it here, right? So what are the coordinates for this red point? It is 2, 5. So our x coordinate's 2, y coordinate is 5. So let's write that there. It's going to be 2, 5. So our answer here is 2, 5. And that is the point that will divide this in a 1-to-3 ratio for directed line segment BA. Awesome work. Our next one says in the figure, point P will be the center of dilation of triangle ABC. Point P is a collinear with the vertices B, C. The scale factor of the dilation will be 3. So our scale factor was times 3. Consider the relationship between the sides of triangles ABC and the sides of dilation in image, triangle A prime, B prime, C prime. Select from the drop-down menu to correctly complete each sentence. So our options here for each thing is be parallel to, be perpendicular to, and lie on the same line as. So remember, parallel means 2 lines that won't touch. Perpendicular means 2 lines that intersect to be a 90-degree angle. And then lie on the same line as means that they would be on the same line. So let's start off. It says AB will blank side A prime, B prime will blank side AB. So A prime, B prime. If we multiply this by a scale factor of 3, it's going to be blown out in the direction of those arrows. And what's going to happen is it's going to be parallel to. So we could write B parallel to. Awesome. And then A prime, C prime will blank side AC. This is going to be the same answer because as we blow it out in that direction, it's also going to be parallel. Once again, B parallel to. But our last one is going to be different. And here's the reason why. If you notice BC, which is the original side of this triangle, it follows that blue line that is being depicted here. And that's the direction of our dilation. That's important. When it follows that line, or if P is collinear with BC or any other side, then we're going to switch it up and it's going to say lie on the same line as. And the reason because is when this happens, what a dilation does is it moves these points outward on this line. You move that point outward. When B and C get moved, they're still going to, BC is still going to be on that same line, or B prime, C prime will still be on that same blue line. So technically it is the same line as. If that line extended forever, then it would be the same line. Cool. Moving on. The diagram represents dilation with the center of P. That is right down here. This is our center of dilation. If the scale factor of the dilation is K, which statement about the diagram is true? Now, a couple things to remember. When K is greater than 1, this is a growth. When K equals 1, stays the same. And last but not least, if K is between 0 and 1, like a decimal or a fraction, then it is a reduction. Those are a couple key factors that we need to know here. Now, if K is greater than 1, which means it's going to be a growth, then the image of ST could be QR. So that means QR has to be bigger than ST. If we look, ST is here. And QR is here. QR is smaller. So that one cannot be true. Next one, it says if K is between 0 and 1, which means that this should be a reduction, then the image of QR should be UV. So QR is here. UV is out here. UV is bigger than QR. So that's not a reduction. So boom, wrong. Next up, if K is greater than 1, then the image of ST could be UV. So if we look, K is greater than 1, that means it's a growth, right? So is UV bigger than ST? Answer is yes. If we look at UV, that's a longer line than it is ST. So there we go. We think we found our answer, but let's just double check. Whoops. Let's go over the last option here. I can't draw that straight line. Let me try. I did it. Clap for me. So there's our answer. Our last one, it says, if K equals 2, then the image of QR is itself. Now, this is a trick question because in our rules, we have an equal sign. So people might see that equal sign and be like, yeah, it is itself. It stays the same. But notice it's K equals 2 here, not K equals 1. That's not true. What would happen is QR would double. So whatever's double of QR, then that would be true. Since it's not, that is not true. So D cannot be our answer. C is the answer here. Just learned a little more about dilation. Next up, we have a little more about dilation. So this one is about transformations and which transformations keep triangles similar. Now, this is important because of the fact that we're looking at transformation rules. So everything down here that underneath the select all that apply are different transformation rules. So I'm going to explain what rule they are, and then we're going to say, does that keep our triangles similar or not? And that's what this is asking. Which of them will keep the similar triangles? For our first one, our transformation goes from our coordinates xy to negative x, negative y, which means whatever these coordinates are, we'll make them negative or opposite signs of what they already are. If they were negative, they would become positive, but if they're positive, they'd go negative. This is technically like multiplying both of these by a -1, and that's all a dilation is. So this is going to be one of our answers because dilations are the only time we keep similar. So that would technically be a similar triangle. And the other key thing is we have to multiply by the same number, our x and our y, to keep everything even. What we notice for our next one, we have x plus 2 and 2y. The same thing's not happening in both of these, so this cannot be the right answer. So, nope. Next up, we're multiplying both by 0.5. This is also going to be an answer. Cool. This is a dilation that we got going on here. Our next one, it says x plus 4, y minus 2. This would be a translation, which means that we're sliding right 4 and then going down 2. And that's where our triangle would be. Now, in some aspects, we could say that this is similar. They are more than similar. They're going to be congruent. But sometimes they will answer these as them being similar. So for our sake, we're going to say, yes, this is true. That's the same thing about our first one. These aren't just congruent. These aren't just similar. These are also congruent, right? And there's a difference there, right? So just keep that in mind. But on some problems, they will count this as the answers also. I know that's tricky, but it is what it is. And our last one, the same thing's not happening to these. So this is not a transformation that we know, or a rigid transformation that we know, or any similarity transformation that would work, right? Because you'd be stretching it vertically more than stretching it horizontally. So here are our answers or potential answers. If it's only asking about just similar, then our answer is only that middle one right here. But if it's asking about similar and congruent, then it would be all of these. Next up, this is just a simple problem. We just have to find our x and our y, right? But the problem here is things don't necessarily match up the way that they look like they should, right? First of all, we need to say, hey, are these triangles similar? So one thing we have to know is that triangles add up to 180. And what that means is if we do 60 plus 40, that's 100. So then 180 minus 100 would give me 80 here. And then down here, 80 plus 40 gives me 120. 180 minus 120 would give me 60 degrees here. Put my degree here. That's one thing to keep in mind. Now we could say, yeah, these triangles are definitely similar. They have angle-angle similarity. Awesome. Now we just have to match things up, right? So let me underline sides that are corresponding. So x is going to be corresponding to 8 because it's between our 40-degree angle and our 80-degree angle. And same thing goes down here for 8. Next up, 3 and 5 correspond because they're between the 80 and the 60-degree angle. And last but not least, 6 and y are corresponding because they are between the 40-degree and the 60-degree angle. Now, with all this in mind, we can set up ratios. And our question here is only asking us to find the value of x. But I'm going to go through and show you how to get y also, just so we can be safe. And so we get a little more practice in. So let's do our x first, since that's our question. We're going to start, and we're going to put this triangle up top on everything, just because it is above. We're going to have x over 8, because they're both the corresponding, they're the green, equals 3 over 5. Because that's our whole fraction here that we're using as a guide, basically. Right? They both got numbers up top and bottom here. Now we cross multiply. X times 5 gives me 5x. 3 times 8, 8 and 8, 16, plus 8 is 24. And then last but not least, we divide by 5. Let me move this because it's making me want to click my buttons down here. 5x, or, oops, divide both sides by 5. We get x equals, I had to take a guess in my mind. This would be 4.8. 4 divided by, let me do my calculator, 5. 4.8, look at me go. That's why I'm a math teacher. All right, let's do our next one. Now, this is the answer to the problem, x equals 4.8, right? But I want to go over how to get y, just as some little extra practice. We could do the same thing, right? Let me switch colors, right? Same strategy here. We're going to say, what color matches up with y up in this top? Purple, right? So 6 over y is going to be our first ratio for y, because they're corresponding. Equals, and we're going to use that same fraction, 3 over 5, because that's our guide fraction, right? And once again, we cross multiply. We get y times 3, give me 3y. And then we get 6, 5, which will give me 30. And this one's the easy one. And when we divide by 3 on both sides, we get y equals 10. And that's going to be the answer for y there. Nice and simple. Cool. Next up, we have another simple one. And this one's already, everything's matched up. It tells you triangle ABC is similar. That little squiggly means similar to triangle DEF with the side lengths indicated. What is the value of x and explain? So all we have to do here is set up the proportion again. So what we could say is that 6 and x are corresponding. And then we also know that 7 and 14 are corresponding. Now, some of you might notice that 14 is double 7. So you could just say that x is 12 because that's double 6. But if you want to really make sure, and one way to show it is by showing your work, because it does say explain here. So you could just set up the ratios like we've been doing. I'm going to say 6 over x, because they're the corresponding, and then 7 over 14. And remember, 6 and 7 are going to be up top because they're in the same triangle. X and 14 will be down below because they're in the same triangle. We cross multiply, right? And cross multiply, we get 7 times x, will be 7x equals 6 times 14 will give me a second, I'm going to do it in my head. 6 times 10 is 60. 6 times 4 is 24. So that's going to give me 84. Right? Then we divide by 7 on both sides. And that, oops, that's a 2. 7 on both sides. And our answer is going to be x equals 12. So that's how we could show the work for kind of what we know is going on here. Boom. And then that works as your explain here, right? So that works as the explain, the explanation. All right, for our next problem here, we kind of have a situation that looks like one of the last questions that we did. Not the very last one, but one of the ones we did earlier. We have that same line segment AB, but now it says segment AB has the endpoints A, which is at -7, 2, and B, which is at 5, 6. What are the coordinates of point K so that point K is on the line segment AK? And AK is 3/5 of AB. So what we could do here is we could use that idea of slope again, rise over run, right? I'm going to show you how to get it in a different way if we didn't have this graph. Remember, it's our rise over run. And the way we could find this answer is, what we could do is find our slope. So our slope formula is y2 minus y1 over x2 minus x1, where our second point here, and since this is a direct line segment, B has to be our second point. We have x2, y2, and then A is going to be x1, y1. So we could plug these in. So this is going to give me 6 minus 2. and then 5 minus a negative 7, which will be plus 7. So up top, we have 6 minus 2 is 4, and then down below, 5 plus 7 is 12. So it gives us the same thing before, right? Except we went from B to A, so these were negative. It was negative 4 over negative 12. But now, since we're going to A to B, and it's a positive slope, it's going to be 4 over 12. Now, with this in mind, what can we do from here? Well, we have this ratio 3/5. So what we're going to do is we're going to multiply both the top and the bottom of these numbers by 3/5. We're going to say 4 over 12. I'm going to say times 3/5 up top times 3/5 down below. Up top, when we do this, and it's going to give us a decimal. So guys, don't be afraid to use your calculator again. But the way we multiply a whole number in a fraction is you take 4, we're going to multiply it by 3, which will give me 12, and then you divide it by 5, which will give me 2.4. Up top here, we're going to have 2.4. Sorry, 2.4. And then down below, we got to do the same thing. So we do 12 times 3, which is going to give me 36. And then we do 36 divided by 5, which is going to give me 7.2. Right? Now, a lot of us are like, what does this even mean? What are we doing with these numbers? So now what we have to do with these numbers, and these numbers give us direction on how to get to K starting at A. And the way we could do this without even using our graph is we just take the coordinates of A and we write them out here. What I'm going to say is A is negative 7, comma 2. And what we're going to do is use these coordinates. Now remember, the top of our rise, which is my y coordinate. And the bottom is my run, which would be my x coordinate. That's important. And the reason that's important is because we have to know which one to add these to. So for my x coordinate, which is your first number in this coordinate, we add 7.2. So I'm going to do plus 7.2. And then for my y, we'll do plus 2.4. And when we add these, we get negative 7 plus 7.2, which is going to leave me with k is at 0.2, comma 2 plus 2.4 is 4.4. And if we need to plot this on the graph, it would be about here. That would be point K. But there is our answer. That line segment that we just created with point K being there puts us in a 3/5 is 3/5 of AB. How we would do it. And I know this is very confusing. So if you are confused about this problem or any of the other problems I went over, as always, make sure you ask me or whoever your teacher is, whether it's Miss Harris or someone else. Ask your teacher to go over it again, ask them certain questions that you may have on the problem, and let us know. We'll be there to help you. Awesome. Thank you, guys.